in this lesson, we focus on monomers, polymers, and making plastics. Let's look at how we make plastics. Now, making plastics, we need monomers. Now, as we say, ethene is a starting material for making many types of plastics. So ethene can be a type of monomer. So monomers, what are they? They are smaller molecules. For instance, ethene, they're very small molecules. But if I somehow join them together, that is called a polymer. Poly means many. The polymer, that's a long chain, long carbon chain, so that's a large molecule. And the monomer, they usually carbon-carbon double bond, means they are very reactive. They're reactive because if you have a double bond, you're reactive and you are called unsaturated hydrocarbon. And the reason is that you can decolorize bromine water. Bromine water was orange color. Once it reacts with a carbon-carbon double bond, it will be decolorized because that double bond is broken into single bond. So whereas polymers, they are carbon-carbon single bond. So they're not reactive, they're unreactive. And because they're single bond, we call them saturated hydrocarbons. And they do not react with bromine water, and therefore the bromine water remains its own color, orange color. So you can tell, you can distinguish the alkyne and alkene, or you can distinguish double bond from single bond by adding bromine water. So if the color disappears, you know it's a carbon-carbon double bond. If the color remains its original color, which is orange, you know it's a carbon-carbon single bond. So what is a monomer? A monomer is a molecule that can react together with other monomers to form a large chain of polymer like this, and monomer joins together to make polymers, and that is the fiber of plastics. Okay, so how do they join together? Let's look at this one. How monomers join together? Because monomers are reactive, because monomers, they have a carbon-carbon double bond. For instance, ethene, you see carbon-carbon double bond. So this is ethene. So if I have 3 ethene molecules, when they join together, one of the bonds opens up and linked with the other carbon. So they form a polymer like this. So they're all becoming carbon-carbon single bond, and this is a saturated hydrocarbon. Okay, so that is called addition polymerization, means we simply add them together. They're all identical. All the monomers are identical. They opens up one of the bond and then they join together. So it is called addition polymerization. Now, if we write, because it's many of those monomers, it's not only 3. It's in reality, it's lots of them. So you won't be able to write every single monomer. So what you do, you write this way. So you have a ethene monomer. So here you have an N, means you have N numbers of these small molecules. And when you join them together, the double bond opens up into single bond, and then they joined with the next monomer. And because it's repeating itself, so we have this repeating unit. We use a big bracket, and then we have an N here, means that we repeat this unit N times. The name is called polyethene. So it's very simple. If the monomer called ethene, polymer will be polyethene. So whatever that name is, you add poly, and then you have a bracket, you copy that name here. That will be the polymer's name. Okay, so let's do an exercise, see whether you have got that. Let's look at one of this work. Now, look at this, saying, what is a monomer? Now, monomer is a smaller molecule. Yeah, we learned monomer is a smaller molecule that contains carbon-carbon double bond. Usually, they're very reactive. So let's say a monomer is a molecule that can react together with other monomer molecules to form large carbon chains. So we can literally just use this definition as the answer to that question. So if I can write in here, that'll be okay. So let me see. So what is a monomer? The monomer is, I think here, sorry. So the monomer is, okay, yeah. A monomer is a molecule that can react together with other monomers to form a large chain of polymers. Okay, that's the definition. Let's give a try here. Say, which of the following molecule could be used as a monomer? Right, which one do you think? Now, of course, it is A. It is A. Now, why? Because it has got a carbon-carbon double bond, and that can be opened up to join with the other. This is a saturated hydrocarbon. No, this is again is carbon-carbon single bond. This is saturated hydrocarbon. No. So will you say, why do you choose? Oh, sorry. Why do you choose this one? Because I need to. Sorry about that. Okay. Because molecule A contains a carbon-carbon double bond. Okay, you've got to have the carbon-carbon double bond to open up and join together. Yeah, molecule A contains a carbon-carbon double bond. Next one, polymer. Now, for the following monomer, they're all monomers. See, carbon-carbon double bond, carbon-carbon double bond. This one again, carbon-carbon double bond. Now you're going to draw the polymer that could be formed from this one. So I'm going to draw this one. So I'm focusing on the double bond. So the double bond, sorry about that. Right, I write again. So you open it up. Okay, carbon-carbon double bond becoming single bond. Open it up. Then you're going to join with the next molecule of the same one. So I'm not going to repeat it. And what I do is to make sure those bondings are bound with fluorine, F, fluorine, 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 and fluorine. And then I have a big bracket here. This is a repeating unit. How many times I repeat? I repeat n times. So if I have n of those, then I will produce a long chain like this. So this is called tetrafluoroethene, and that will be polytetrafluoroethene. So that's the polymer, draw the polymer. Okay, let's look at this one. Same, very simple. I have to write in here, again, double bond is broken into single, double bond broken into single, and then you're going to join up with next identical monomer. So here is a, don't forget here you got bondings, okay, bonded with what? Here is 2 hydrogen, okay, hydrogen, hydrogen. Here, hydrogen and chlorine, hydrogen, chlorine atom, chlorine, okay, Cl, that's Cl. And then you have a big bracket, means a repeat n times if you have n of those. So that is the form polymers structure. Now, last one is a propene. You see, 1, 2, 3. So that's a propene because it's double bond. Again, concentrating on the double bond. Right, concentrating on double bond. Right, this concentrate on these two bond. Please don't get confused with this one. Concentrating on this one. Right, so this carbon, you got two hydrogen bonded. Okay, two hydrogen here, hydrogen here. Okay, this carbon have one hydrogen here. Okay, I'm not going to change that at all. Here, bond with a carbon, and three hydrogen. Now I have three hydrogen. You can write this way, CH3. You can write this way, right? And then you join them together because there's lots of them, identical ones. So repeating unit is N. So that's propane, and that will be polypropane. Yeah, so that's N of those. Will produce N of those. Okay, so I hope you understand the relationship between monomers and polymers. All right, so let's look at the name and their uses. You see, they are the monomers. You can see that's ethene. See, carbon double bond, ethene. And then when they becoming polymer, it's polyethene. And then that's repeating unit in big bracket and N. So those kind of polymers are used for bags, toys, and this sort of plastics. You can see, so strong and flexible. Okay, clean film, things like that. Now, if we have propane, we done that earlier, propane, then the polymer will be polypropane. And this kind of polymers, they're used for ropes and the milk crates and the Christmas packets and carpet packings and so on. So they're also very, very strong and flexible. Yeah, that's polypropane. And you have this chlorine here, so you call it chloroethene. Eth means two carbon, and it's a double bond, so it's ethene. But you got chlorine here, so it's chloroethene, that's monomer. And the polymer will be polychloroethene. And this kind of polymers is very good for window frames and water pipes because they're very durable, very, very durable, tough, right? And this one here, you have 4 fluorine. 4 means tetra. Tetra means 4. 4 what? 4 fluorine atoms. So fluoro. And eth means 2. 2 what? 2 carbon double bond. So ethene, E-N-E, means double bond. So that's called tetrafluoroethene. And when it's polymer, it's poly, in bracket, copy it down, tetrafluoroethene. So that's how you write the polymer. And this kind of material are tough but slippery. So you use for the frying pans, it's non-sticky frying pans. So it's very good for that sort of use. And last one is styrene. Styrene, see, this is again carbon double bond. This hydrogen, but this one have a ring. See, a benzene ring. So it's the same thing. You just copy this carbon, you got 2 hydrogen, see the carbon CH2. This 2 means these 2. This one's CH, this H is this one. And here you have this rings here. And then that is the polymer. And this kind of thing, you see, those plastic mugs, cups, yeah, we use for that. It's a very, very good insulator. So good insulator of heat and electricity, very low density, so very, very light. So we use that for insulation and the electric socket and so on. Okay, so this lesson is about monomers, is about polymers, it's about how to make polymers from given monomers. So you understand the relationship between monomers and polymers. You need to be able to write up the polymer's structure if given a monomer. Or if I give you a monomer, you need to write the other way around. So, okay, I hope this lesson helps, and see you next time. Bye!